was burned, it was like James Dean. For sure, you're so fresh to death and sick as cat.
Okay, 6.2 is very similar to what we did last day. It's called investments using compound interest, and we did that last time. We looked at investments with compound interest. But what's different with today's lesson is we're going to look at what if the interest is not compounded annually. In other words, what if you get the interest more than one time a year? So just to show you what I mean, if we go down to the table here, we got some important words here, and the one that you've talked about so far is annually. If you get interest calculated annually, how many times do you get interest per year? Once. It's an annual thing. It just happens once per year. But if you get interest and it's calculated semi-annually, how many times do you get interest per year? Twice. Quarterly. Now quarterly doesn't mean every 4 months. It means 4 times per year. So the number of compounding periods per year is 4. Monthly. How many times would you get interest if you got it every month? Well, in 1 year you'd get 12 times you'd get the interest. And daily. How many times would you get interest if it was compounded daily? You'd get it 365 times. Except on a leap year, you get 366, wouldn't you? Okay, so that's what I'm talking about. What happens, what's the impact, and how do we calculate it if you get interest more than one time per year? So what we're going to start with is the same formula we had last time. A equals P, 1 plus I raised to the nth power. Just like last time, A is the total amount that you now have, and P is the principal, the amount of money you started with. What's a little bit different is what I and N stand for. So before, what we said that I was the interest, and it was the annual interest rate. But now what we're looking at for I, it's the interest rate per compounding period. So you need to figure out, okay, for example, maybe they give you the interest rate for the whole year, but if interest is calculated every day, you got to figure out, well, how much interest do I actually get every day? So it sounds complicated. It's actually not that confusing once I show you an example. For N, last time N was the number of years that your investment was in the bank or whatever. Now what N is, it's the number of compounding periods. Because again, just because you have your investment in the bank for 2 years, it doesn't mean that you're going to get 2 compounding periods necessarily, because what if you're getting interest every month or something like that? So again, it's not too difficult to figure out, but you have to be aware of that. So let's go through those right now. How do you figure out the interest rate per compounding period? Basically what you do is you take the annual interest rate and you divide it by the number of compounding periods per year. So for example, let's make an easy example. Let's say that you get 6% interest annual interest rate, right? That's your annual interest rate. But you get interest compounded every month. So you're actually getting 12 times you get the interest per year. You have to divide the 6 by 12. Actually, turns out you're only getting 0.5% interest per month. Yeah, you're getting 6% per year, but that works out to 0.5% per month. It'd be really nice if you got 6% per month, but you don't get that. If this is an annual interest rate, you have to divide by 12 to get the monthly interest rate. Okay, similarly for number of compounding periods, you can take the number of years and multiply by the number of compounding periods per year. So let's say you're going to put something, an investment in the bank for 10 years, and you get interest calculated, let's say again monthly. Well, you don't just get 10 compounding periods, you get 10 times 12, because you get it 12 times a year. You have 120 compounding periods, which is a very nice thing. Okay, so that's important, both of those things. Okay, I think this will help us, this example will help us with what we just did. It says, this is our example, $4,500 invested for 6 years at an annual interest rate of 8%. Complete the table. We've already done the first column. Total number of compounding periods. So this would be the first formula, or second formula, the number of years times the number of compounding periods per year. Well, in every single one of these cases, whether it's annual, semi-annual, quarterly, it's always 6 years. So it's going to be 6 times something and 6 times something and 6 times something, all the way down. And then what you're multiplying the 6 by is the number of compounding periods per year. Well, we just figured that out right here. So in the first case, it would be 6 times 1, 6. This would be 6 times 2, 12. 6 times 4, 24. 6 times 12, 72. And 6 times 365 is 2,190. Does this make sense? I mean, you don't really need to memorize the formula. You just need to think about this. If you get 365 compounding periods per year, you get interest 365 times a year, and you're putting it in there for 6 years, then it's 365 times 6 is the number of times you're getting a compounding period, or getting interest. Okay, the next thing, interest rate per compounding period. This is this formula. You got to take the annual interest rate. In this case, the annual interest rate is 8, and you're going to divide it. So it's going to be 8 divided by 8 divided by 8 divided by. They're all 8 divided by. And what you're dividing by is the same thing, the number of compounding periods. Well, that's that number again. So in the first one, it's 8 divided by 1, which is 8%. Then we've got 8 divided by 2, 4%. 8 divided by 4, 2%. 8 divided by 12, 2/3 of a percent, or 0.6 repeating percent, I suppose. And 8 divided by 365, that's just ugly. You get some crazy decimal. I'll write some of it, 0.0219%. I'll stop there. That's a 0. Okay, to get the amount, well, you got to use your formula. Remember the formula which we've written up above. A equals P 1 plus I raised to the N. You're going to use that formula every time. So in the first case here, in all the cases, you're going to have 4,500. That's the P amount. Then you're going to go 1 plus I. Well, I is 8, but you don't go 1 plus 8. You turn this to a decimal, so that's 0.08, right? So 1 plus 0.08 is 1.08. You raise it to the nth power, which is 6. This is our N value right here. You get 6. And if you do that, first of all, do the exponent, then multiply by 4,500. You're going to get $7,140.93. Okay, similarly for all the other ones, maybe I'll just show one more. You'd go 4,500 again. This time would be 1.04, and it wouldn't be to the 6th this time, it'd be to the 12th power. And if you do that, you would get $7,204.64. And it keeps going. As you probably guess, it gets higher and higher, a little bit higher and higher, because you're getting interest more often. But remember, the interest you're getting every compounding period is also going down. It went from 8%, you're all the way down to 0.02% here. So when you get interest quarterly, the amount you're going to have, I'm not going to do this all, you can work it out for yourself. You're going to get $7,237.97. Then when you go to monthly, it's going to go a little higher, 7,000, that's a dollar sign, believe it or not, $7,260.76. And when you get to daily, it's going to be all the way up at $7,271.95. So you can see, by going from annual to daily interest, you end up with about 131 extra dollars. Not too bad. Now at this point, many people ask, well, what happens if you got interest even more often, like every hour, or every minute, or every second, or every millisecond? How silly can we be? Well, we can be really, really silly in math. You could imagine getting interest continuously, it's called. This is actually a thing, continuous interest, which means you're getting interest every second, every millisecond. It's just constantly getting interest. So at first that sounds like, that's fantastic. I mean, the number of compounding periods you're going to have is an infinite number of compounding periods. That's the good news. The bad news is your interest rate is going to be so small, because you're going to have to do 8 divided by an infinite amount. You're going to have almost 0. Your percentage that you're going to get every time is almost 0. It's infinitesimally more than 0%. So what do you think? What's going to happen? Well, it turns out there's a formula for this, for continuous interest. It's A equals P times R raised to the R times T power. It's called the shampoo formula by some people. I know that's stupid. Why is it called the shampoo formula? PERT, right? You heard of PERT, the shampoo? Anyway, the way it works is you plug into A is the final amount, so we'll figure out what that is. You plug into P, the principal, which was 4,500 in this case, just like above. E, what the heck's E? E is Euler's number. It's a famous number like pi. You know, pi is 3.14. Well, Euler's number, named after my favorite mathematician, it's 2.71828, and it goes on and on and on. It's also irrational, just like pi. But there should be an E button on your calculator, so I'll just put E there. You're going to raise E to the R times T. R is the annual interest rate, so that's 8, but we put it as a decimal, 0.08. And T is time, and I believe we're putting it in for 6 years, aren't we? Yeah, it says 6 years. So if you multiply 0.08 times 6, you're going to get 0.48. You raise E to the 0.48th power, multiply by 4,500, and the amount you will get if you do that is $7,272 and 33 cents. So it sure sounded exciting to get interest every millisecond, every moment of our lives, but the interest rate is so low that it turns out you only get, what, an extra 38 cents from daily. So daily to continuous really is not a big deal at all. But still, it's a pretty cool concept, continuous interest, and you'll talk about it in calculus, I'm sure. All right, on to annuity. Annuity is a series of equal payments made at regular time intervals. So the key here with an annuity is it's a payment. You're now going to start making payments. So think about it like a savings account. Let's say you have a job and every time you get your paycheck, you put $100 in the bank. That's an annuity. It's a regular savings plan. Or in a couple more sections, we're going to talk about paying off loans. That's an annuity too. It's an agreement where you're paying off every month a certain amount of your loan or your mortgage, which, as you know, is a loan on your house. So these are examples of annuity, and that's going to pop up in some of these questions. So we've got 4 questions. They're very similar in some ways. You're going to use your TMV solver for all these. Okay, here we go. Matt has invested, well, maybe what I'll do is I'll highlight the numbers here. Matt has invested a $23,000 inheritance in an account that earns 13.6% compounded semi-annually. The interest rate is fixed for 10 years. What will be the value of investment at that time? So let's start by putting in the information we know. N's the number of compounding periods. So you might think that answer is 10 because it's going to be in for 10 years. But that's not the case. Why not? Because it's semi-annually, which means you get interest twice per year. So if you get it twice per year and you put it in for 10 years, 10 times 2 equals 20. That's your N value. Okay, the interest percentage, 13.6%. Easy. PV, remember it stands for present value. That's like the amount you're putting in to start with. And that is this amount right here, the 23,000. Remember, since you're putting it in, you're kind of taking it out of your pocket. It's a negative amount. 23,000. You don't have that with you right now. 23,000. Payments. Are you making any payments? We just talked about this annuity. Is there any annuity here? No, you're just putting the money in and you're leaving it. So that's 0. Future value, that's what we don't know. So I'll put a question mark. You're not going to do that in the solver, but I'll just put that there to show you that's what we're figuring out. Payments per year, well, there's no payment, so I'll put 0, right? No, this is that really weird thing about the TA83 solver, is that if there is no payments, and there is no payments in this case, you always make the number of payments equal to the number of compounding periods. I know that's bizarre, but that's what you do. So how many compounding periods are there? Well, it's semi-annual, so there's 2 per year. And as I said, if there's no payments, the payment number, this thing right here, has to be the same as this one. So this one's also 2. Bizarre. End or begin, we said always put end unless it says otherwise in the question. So that's the information we're going to put in. So let's go to the solver I used before. Here it is up here, zenwealth.com, business finance online, TVM calc window. Wow. And let's put in the information. So PV we said was $23,000. The rate, or the interest rate, is 13.6%. The payment, there is no payment. The number of periods, that's the N value, that was 20. The future value you don't know. You can just keep it, or I'll delete it in this case. And the way this one works is you pick it here, and it says semi-annually. So there you go. Now I want to know the future value, so you go down here and you click future value, and I get $85,733.96, and that's it. So I go back here and I just put the answer and I'm finished. $85,733.96. Please note, you would, on a quiz or test, you would need to include this information as well to get full marks. Okay, but you're going to be able to use your TVM solvers, so that's good news. Okay, second one. Agnes and Bill are musicians. They want to set up a recording studio. They estimate that $40,000 will pay everything they need. They plan to set up the studio in 3 years and have invested money at 9.6% compounded quarterly to save for it. How much money should they have invested? Okay, this time maybe let's start at the bottom and go up. Maybe that's better. So it doesn't say anything but the beginning, so obviously it's the end again. Compounding periods per year. Well, it's compounded quarterly, so that's going to be 4. Is there any payments on this? No payments. So remember, this is that weird thing. If there's no payments, this one here has to be the same. These two have to be the same as each other. So this is also going to be 4. Future value. Do we know the future value? Yes, in this case we do. They know that they need $40,000. That's how much they want to end up with. So $40,000 is the future value, not what they're starting with, what they want to end up with. Is there any payments in this question? No, no payments. What's the present value? We don't know. That's the question. How much should they invest? So that's my question mark. The percentage is 9.6%. And how many compounding periods are there? Well, there's 4 per year. It's quarterly. And they're going to leave it in for 3 years. So 4 times 3 equals 12. All right, we're good to go. Back to our website. And we're putting in the numbers. The present value we don't know, so I'll just leave that blank. The rate is 9.6%. The payment, there is no payment. The number of periods was 12. That's the end value, right? The future value, what they want to end up with, is $40,000. Remember, that's positive because that's money in your pocket now. They actually have that money, and it was compounded quarterly. What we're trying to figure out is PV, the present value. So we hit PV right here, and you get negative, and that's what present value is when you put money in the bank, $30,092.66. So there we go. We'll type that in, or write that in here. $30,092.66 is our answer. Okay, I think we now have some payments in this one. Annuity. Jeremiah deposits $750 into an investment account at the end of every 3 months. Interest is compounded quarterly. The term is 3 years, and the future value is $10,059.07. What annual rate of interest does Jeremiah's investment earn? You don't know the interest. Interesting. So this is the one we want to know up here. Okay, let's start at the bottom again. I like that. So it doesn't say anything about the beginning. Oh, it actually says here at the end. So we know it has to be the end. He's putting deposits at the end of every 3 months. How many times is it compounded per year? It's compounded quarterly, so 4 times per year. How about payments? Now there are payments here. So what's it say? He's making a payment every 3 months. So that means how many payments per year? Also 4. Future value. We've got that right here. $10,059.07. How much is his payments? Payments are $750. That's what he's putting in every time. Now be careful. He's putting that money into the bank. It's out of his pocket. So that should be a negative number. Present value. How much does he currently have? None. This is right when he's opening up the account, and he doesn't put money in until the end. So the present value is 0. There's actually nothing in there right now. And how many times is he going to get interest calculated? Well, he gets it 4 times per year, and he's leaving the money in for 3 years. So 4 times 3 is 12. Here we go. The present value is 0. The rate that you're getting is, we don't know. That's the thing we're trying to figure out. The payment that you're putting every time is a negative amount, and it was $750. The number of periods is still 12. The future value was $10,059.07, and you're getting it quarterly, so we'll leave that like that. We want to know the interest rate, so you hit rate 8%. He needs to get an 8% interest rate in order for this to all work out. Don't forget the percent sign. Last one. Cameron has $12,500 in a savings account. He starts depositing $500 into the account at the start of each month. If the rate of interest is 6.4% compounded monthly, then how much money will be in Cameron's account after 10 years? Okay, let's start at the bottom again. And here we come to the problem. Because if you look, he starts depositing money into the account at the start of each month. This has to go here. We have to look at beginning. And if you go and look at my calculator I've been using here, it doesn't give you the option of switching to beginning. It always does the end, unfortunately. So we're going to have to use either a different online calculator or the TI-83. I guess I'll use the TI-83 since you probably will be using it in class anyway. It's probably good for me to show you using it at least once. Alright, compounding periods per year. It's compounded monthly, so 12 times per year. How many times is he paying? He starts depositing $500 into the account at the start of each month. Oh, so it's also 12. He gets 12 payments per year. The future value, that's what we want to know. We want to know how much money he ends up with. The payment, how much does he put in each month? $500. He's taking that out of his pocket and putting it into the bank, so negative $500. Present value, what's he start with? $12,500. Again, that's out of his pocket in the bank, so negative. The percentage is 6.4%. Remember, this is all these questions we've done here. This is the annual interest rate, but if you were actually going to work this question out by hand, you would have to take the 6.4 and divide it by 12 in order to figure out the interest rate per compounding period, because you're getting interest every month. This is the annual interest rate, so you go 6.4 divided by 12. We talked about that on the other side of the page. And how many times does he get interest? Well, he gets 12 times per year, and he's leaving the money in for 10 years. So 12 times 10 is 120. And off to the TI-83. So give me a second here. Okay, here we go. So remember, we're going to hit second, and this one for finance. Hit number 1. And here we go. Our N value is 120. I'm going to use the keyboard. It's faster. The I is 6.4%. The present value is negative, so I got to hit this button right here. 12,500. The payment is negative. I got to hit this button right here. 500. We don't know the future value. The number of payments per year is 12. Number of compounding periods per year is 12. And then I need to move this over to beginning. I hit enter, I think, right here. And now that's good. I can go back up to future value. And finally, I hit alpha and enter. It's a bit more work, isn't it? And I get the amount. Wow, way to go, Cameron. You've got a pretty hefty size in there. 107,855.34, I guess, if we round up. So let's go write that down. The answer is $107,000, 855.34. Good for you. Now, you might be wondering, big deal, this beginning and end thing. Would it really make much difference? Well, let's see. Let's go down, switch it to end. So I'll hit enter here. Go back up to future value and then do the alpha enter again and see how much difference that makes. And you see we now have $107,408.71. So let me write that down here for comparison's sakes. $107,408.71. This is if it was at the end, and this is if that was at the beginning. So, you know, it's over a long period of time. It's 10 years. But just by getting the interest at the beginning rather than the end of each month, you end up with an extra $450 almost. So you can see it is important for accuracy for answering these questions that you make sure you put either beginning or end. The payments, if there's payments involved, it's usually going to be beginning. Otherwise, if there's no payments, I think it'll always be the end. Take care.
Baby, can you see through the tears? Love you more than those pictures before I